Hello everybody, and welcome to a video of Programming for Data Analytics Part 2. Today's topic is going to be, as you see there, regular expressions. Last time we were talking about regular expressions, but today we are actually going to get to do some of them on the computer. So if you didn't understand some of this information from last time, or it was a little bit confusing, then hopefully it'll be clarified now as we actually try some of these fancy things like the meta characters and escape sequences and all, the different sort of weird syntax of regular expressions. And in addition to coding it just in Python, I actually want to start by showing you a really cool website that allows you to play around with regular expressions. That website is this one right here that you see up there. It is regex101.com. And I'm not affiliated with this website or anything, but I personally think it's a very, very useful website to explore regular expressions. So I'm actually going to start by just showing you that website so that you can kind of see what it does. And I think we'll refer to it as we try to come up with some regular expressions, because I'm sure you realize by now they can be very tricky. In fact, when you're developing regular expressions, you want to test them to make sure that, just like you test code before you deploy it on a large amount of data, you want to test a regular expression to make sure that you're actually writing what you expect and the semantics of what you're doing is correct. Even if, it's easy to do the correct syntax for a regular expression, but your semantics might be wrong. So you may intend to find one or more characters in that position when you accidentally write 0 or more characters because you use the clean star instead of a plus symbol and things like that. And so what you want to do is you want to write your regular expression and then maybe test it with a small subset of your data, like a little prototype. And then you know what the answer is for that because you manually checked it. Let's say that you're looking for a specific keyword in the paragraph. And so you know that actual keyword is there. So if you were to test it, you would expect to get back that location, right? So this is the kind of testing you do in your regular expressions to make sure that they're doing what you expect. Now, this is not to say it is the only way to figure out if something is right or wrong, and it's by no means exhaustive, but it can at least help you catch the majority of the big errors. And of course, everything else is about doing your due diligence and kind of ramping up until you run it on your full data. So let's go ahead and switch over so you can see that website. So this is the regex101.com. And so it's really cool. I actually, I was messing with it and playing. So here, let's just refresh it. I guess when you refresh it, it's got everything stored in it. But here we go. Okay, so you got two spots. Up here, you're going to go ahead and write your regular expression. And then down here, you're going to write whatever string you want to test it on. So maybe it's like your prototype, your paragraph. And the really nice thing about it is, in addition to telling you if that regular expression returns any matches, it explains to you how the matches work. So if you're just learning regular expressions, as you probably are if you're watching this video, you can actually see kind of like a verbal description of what they do. This can also be useful if you run into someone else's code that's using regular expressions, and then you don't understand or remember how that specific piece of code works. You can just plug it in here and then it'll tell you. So for example, if you remember, the square brackets allow us to search for a range of ASCII characters, right? So if I say something like A through F, what this is supposed to do is search for any matches that contain the letters A through F, right? And as you can see here, that actually explains that. It says match a single character present in the list below, which is A through F, matches a single character between index 97 and index F102, which is the ASCII table matches. In fact, I can't remember remember we were doing it, I think lowercase s it was. No, that was like 99 or 83 or something. I forgot what letter we were trying to match. Uppercase S, I think, was 83. Maybe that was it. That was the one that we were trying to match in the last video. So this is nice. It even tells you the ASCII, but more importantly, it tells you what this is doing. So like more fancily, let's say something with the clean star. So like, let's say that we were looking for the word marker, but where the E is, we can allow repetitions of that. either 0 or more. So we put an asterisk to do that, right? A clean start. So let's see what the description here says. It says, and by the way, I welcome you as you're watching this video to, if you have two monitors or if you just want to make this not full screen, to open a page of regex 101 and please try these along with me so you can try other type of variations of what I do. And in general, again, as we're doing the ones in Python, you can also test them here if you don't have Python handy because this is just a website. But you could also, I guess, run this on the Python interpreter online. But yeah, so as you can see here, the word marker, but we have the E and the asterisk. The word mark here matches an exact match, and it has to be case sensitive, meaning that it has to be lowercase m-a-r-k. And then from there, you can see that the letter E is next to the clean star. So this is the one we're going to apply the clean star to by saying that we can have 0 or more matches, right? Because that's what the clean star does with the asterisk. And as you can see here, where would we see that? E matches the character E with index that, R matches the character R with index that. Hold on, I think we can click there. Here we go. Yeah, so we can click the little down symbols here. This is saying that it's match exactly the M with an M, the A with an A, the R with an R, the K with a K, and then from there, the E, there's the asterisk. So we hit the little down symbol here to see the details. It says matches the previous token, which is the E, because it's next to the asterisk, the previous token between 0 and unlimited times. See, this could have said like the same definition as I said, like 0 or more occurrences, but that might be a little too technical. But people understand the word unlimited better. So 0 and more, or 0 and unlimited times, as many times as possible. See, it's even like repeating itself just to make sure that you really understand, giving back as needed. Okay, so that it's trying to make it into layman terms, and I think it helps. It helps to refresh your mind about what these things mean, especially what the symbols mean, because then you'll be like, oh, okay, clean start, that's right, that's what it does. Now it all makes sense. Anyways, after that, we have to match with an R. So let's test this on a string and see if it actually works. So I'm going to say I am writing on the board with a red marker and a blue marker. Okay? Period. So as you can see, and by the way, this is what I was testing right before the start of the lecture, do not put quotes around it up here. We're used to putting quotes around strings in Python, but in this website, you don't need to put any quotes because the entire thing is assumed to be the regular expression. I guess similarly with the string, although that really won't make much difference. It'll just make part of the text. But yeah, so don't put any quotes on this website unless that's what you're searching for. So as you can see here, it's cool because it highlights it. It's like, okay, these are your two matches, and you'll see this keyword. We might look at that later. That's one of the functions that you have available in Python. But yeah, so you can see that there's two matches, right? The word marker in this case is appearing, again, the clean star is affecting the E, so it's 0 or more. In this case, it's 1, which is between 0 or unlimited amount, okay? What that means is that I could also make one of these have like 50 E's in it, and this would be okay. Because in this case, the clean star is applying it to, I guess, how many E's there are? 2, 4, 5 E's, okay? If I go in and put in like a T in there though, marketeer, then it fails because it can have 0 or more E characters because the clean star is affecting the E. So this is something that I don't think I pointed out or was very clear in the last video when I was doing it in the lightboard. The meta characters, they have to affect a specific character, and so the normal way to do it is that they affect the previous character that was in the string of the regular expression. Okay, so if I'm putting in a plus, if I'm putting in an asterisk, if I'm putting in a question mark, I suppose those all affect the character before. Okay. That's not all that to say that all the meta characters work that way, because you saw the brackets are just the brackets. You can't say like a range in between, and then the dot is kind of like your placeholder or your wild card. So, but at least for things like the asterisk, the plus, the question mark, and some of the special escape sequences, that's the way that's going to be. Okay. So, anyways. In this case, this fails because so far this part is good. In fact, if I put a space in here, you'll see that that actually would match. Oh wait, I guess not because we have the R. So I'd have to put a R there, and that would match okay, even though there's two E's because again, the clean start, right? The reason why it doesn't match with this is because the T, it wants to see an R there, and it sees a T and other stuff, so it fails. Now, if I switch that to an R, then we will have a match. Because, you know, it has the M, the mark, the EE, and then the R, and then the rest of the stuff is like, whatever, I don't care. I made my match already, and so on, okay? So if I go in and remove like the A, or well, I guess put a slash, a backslash, that of course breaks that match, and so on. So this is a really cool website. Very nice, very nice. Let's actually switch this to be a plus, so you can see the description of that one. And I'm sure I'm going to run into some mistakes today, and we can ask this website to see what's wrong and figure out ourselves. Here you go. So now it's a plus. So it says between 1 and unlimited time. So see how that switched? Let's switch it back to the asterisk. Ready? 3, 2, 1, switch. And this is 0 and unlimited time. So let's switch it to a question mark. It says matches the previous token between 0 and 1 times, as many times as possible, given back as needed. It's a weird way of writing that, but okay, it's right. It's right. Let's see if we want to match the word marker or blue, or no, because it's next to each other, or board. Okay, in this case, we're saying match either marker or match board. Let's do another or match letters in the range of X to Z. Oh wait, see, did that match X W X Y Z? Yeah, of course. I was in my head. I was like, I want to match the W so you can see the W, but X is after W, so I'll match there. But yeah, so now we got something with a matching with the W here. We got the board matching from this or. We got another W that matches, and then we get the marker that matches that. So as you can see, already our query is starting to become a little bit more complicated. We can find all the words. I mean, we could say something like or R and find all the letters that start with R. But let's just say that we say something like starts with R. Let's see if that's doing what I'm thinking. Asserts position at start line. Oh, by the way, there's a little question mark here. It allows you to read more details about things. So it says R matches the character with index literally. Oh wait, that's the R for marker. The caret asserts position at start of line. So for example, actually, oh no. This one's the one that goes before. Yeah, there we go. Okay. So actually, I'm trying to make it match the word red. Why can't I get it to match red there? So let's see. R matches the character. Asserts the position at the start of the line. Let me see my notes here for a second. I think that's right. It's for line feeds. So I think it's like if I had multiple lines. So like, hello, I am writing with red marker. Yeah, there we go. Okay, right. So the caret is for capturing within text. You can have line feeds, and it's specifically looking for new lines that start with that given sequence. So if I say just R, then it is trying to look for matches that start with that. Okay, with that pattern, which I gotta give it a pattern though. So here R, there we go. So as you can see, that's matching that. Let's get rid of the other ones just so you can see that only matches that. So there you go, that's matching that. In this case, I guess this wasn't exactly that clear. Well, actually, no. Start of a line. I guess technically it is clear. Well, I mean, it's weird. It's clear once you know what it is. So is it really clear? Maybe. And then, of course, the opposite, which is the $sign. So like for ending the line with something. So let's say we want to find lines that end with a period. Oh, okay. Well, I'm kind of glad we ran into this situation. So in my head, I'm thinking, oh, well, let's go ahead and find lines that end with a period. However, you can't just do that because the period itself is a special meta character, right? That represents any character. So what this query is looking for is basically any character except for new line characters to end the line with. And so it's like basically matching every single scenario. That's why every single line is being highlighted. Let's try something other than a dot and come back to the dot. So maybe let's find sentences that end with an O. Get rid of all this stuff. As you can see now, we found not sentence but line that ends with an O. This one ends with an O, and by end I'm saying it's a completely new line. So I can write stuff in front of it. So I can just spam words and everything. It's still saying that it's matching this line because it's ending with an O. If I switch this from an O to, do any of these repeat more than once? Not really. I think we all have them. They all end with different words. But if we, here, let's put another one. Affleck. I'm not thinking Affleck. I was trying to think something that ends with an A. Monica. There we go. So that ends with an A. So now we have two matches. Okay. But let's go back to the dot because that's an interesting scenario. That's basically like your wildcard, right? So if I'm looking for the word with, but I want this to be anything, I can put in the dot and it'll match anything that would fit there. So for example, if I write the word, I know it's not a real word, but if I write the word what, I guess, then that would match too because this is your wildcard. It's basically fill the dot with whatever. I don't care, anything can go there. In fact, I could put in a number in there. That would be okay, but it has to be a single character. If I put two characters, then there's no match. Single character, there's a match. See how nicer it is when you have a computer? That's another thing I wasn't a fan on the previous video with the light board. Here you just have the power to test things versus on the board. So, plus I got dizzy on the last video, as I told you also. No more light board for this class, but yeah. So by the way, make sure you're watching this video in 1080p HD so that you can actually read the text. Otherwise, it's going to unfortunately be small. Now, I can try to make it a little bit bigger, but then the problem becomes that it's a little crowded now. But yeah, okay. So moving on, like I said, we want to try that weird scenario, right, where we want to end things with a dot. So, but we know that the dot is that. In fact, here something as simple as I want to find in here the following pattern: 1 2 3 dot 1 2 3. Okay, and then there's other stuff around it. So I want to find that match. So if I try to do 1 2 3 dot 1 2 3. I might be like, oh yeah, well, this is the right match. Oh, just putting a dot there is giving me the match. But is that really what you intended? If you just wanted to find that dot as the exact match? Let's see what happens when I try to do the same sentence. But instead, I put in 1 2 3 4 1 2 3. That's matching true, right? Because the dot is a special meta character. It's not actually matching a dot. So then you might be asking okay, what do I do? How do I escape this dot? And I told you this last time, but think about Python. What if you in Python? So imagine this is a Python interpreter for a second. Actually, here, let's just switch over to the iPad. What if in Python I'm trying to write the following string, hello, or actually, he said. Hello. Okay, that's the string I want to write in Python. And so if I ask you how do I print this out? Well, there's two ways. One way you could do is just put single quotes around this and call it a day. But what if I said, well, I really want you to use single quotes too? Or sorry, double quotes. If you do this, then you're going to run into a problem because the interpreter is going to assume that this is a string right here. And then that this is some sort of string, and then it's going to be what is this? Is this some variable, and why is it all squished together without being commas or pluses or something, right? So it's going to error out. So if you remember from 621, the way to actually print out a quote in Python and not run into this problem is to use the backslash, right? So use the backslash for that, and use the backslash for the other code that's actually meant to be printed, and it's not meant to be a signal to Python that this is the beginning or end of a string, right? And that is, this right here is what is known as an escape sequence character, right? And so that's how you do that. In fact, if I ask you, what if I actually just want to write a backslash in Python? So like, what if the string I'm trying to print out is like hi backslash, like maybe like an emote. It's a little emote, so you know, it's like a little colon there, so it looks like a smiley face or whatever. Well, again, if you try this, it's going to get confused because Python's going to think you're actually trying to do an escape sequence character. So how do you fix it? You double them up. So now this escape sequence is the escape sequence for that. And so they're like multiplying, right? In fact, there's a term for this, which is the backslash plague, which we'll get to in a little bit when we get to Python, right? But anyways, going back to what we're doing over here, you know, we can use that same sort of concept to get around this issue. We can use a backslash in front of what would otherwise be considered a meta character, and then we fix it, okay? And you can see in your description it says here, matches the character dot. See, backslash dot matches the character dot. Would have been cool if it said like, oh, by the way, this is an escape sequence, but it doesn't seem like it does that. So, not as, I mean, it's still cool because there's some explanation, but I was hoping that this will have an even cool explanation saying the backslash is escaping the dot so it doesn't think it's something else. Okay, so like I said, I welcome you to explore with this website. It's really cool, and it's really, really great for just testing things. As you saw, we would have known if we forgot that we needed to do this backslash, you know, this would have given us a warning, hopefully, that this is not what we meant to do. Obviously, for that, we require some good testing, right? So, you know, coding is an art, of course, but unit testing, in other words, or just testing your code is an art of itself, too. You have to consider the edge case scenarios. If you wrote this wrong and in your test all you had was this lines here, but you didn't have this line here, then your testing would not have caught the error, and that would have kind of slipped through. So you have to think of the edge cases. Like, okay, and of course, when you're thinking of the edge cases, you know, you were probably already thinking like, well, did I handle that edge case? So like, the act of me putting this is because I know this is wrong. But like, if I didn't know it was wrong, how can I make this test? That's not easy to do. And that's just something you kind of just, you know, you try your best to think about weird case scenarios. And even though you know your code should be okay, you still do them because then you really know if it's truly okay. And, you know, that's all I can say. Just keep throwing as many weird things as you can to try to break your own code so that you fix it and not your boss sees a problem and then tells you to fix it, but not you how to fix it because you got yelled at, not because you fixed it before anybody could see it. Okay, so that's what I want to say about that website. So let's go ahead and start coding some Python. So I'm going to move this to the side. And here we are, Python. All right, so this is file 1. So I actually went ahead and, I mean, we're going to play around with this, but I thought it might be useful to have a large piece of text just in case you want to try to do some queries that are fun. And as you can see already there, I was exploring it, you know, doing some queries there. And so what I downloaded from the Gutenberg website is the time machine as a text file. So this is not piracy because this is in the public domain now, so I don't think I'm pirated something. What is the Project Gutenberg? Here, let me just pop the website open. This is Project Gutenberg, and they basically host a bunch of books that are in the public domain to kind of spread knowledge, and you know, I pretty much read all the cool novels, like old school novels. And so from here, I just went ahead and I looked at Time Machine, and you can see it, H.G. Wells. Okay, and I downloaded the plain text version. This is Gutenberg.org. So if you want to download it, it will be within the repository of all the code that I usually post. So all this stuff, just like in 621, I will have that file. But if not, either way, you can just download it from Gutenberg directly like that. If you click on that, it actually gives you the text. So I recommend you right-click on it. Let me scroll that up actually. Right-click on this, and then hit Save. So I went ahead and I brought that into my VM, and so let's go ahead and do a quick refresher of how do we actually open a file in Python, right? So I went ahead and put a file right here. So there's a file within the same directory as my Python script. That should make things easy. And now all I want to do is just open it. So I'm going to say the word open, right? That's the cool thing about Python. It's very simple. Now the file is called the time machine hgwell. So you're going to make sure you get the file name right. Gutenberg.txt. I want to open it in read-only mode. So, or you can use single quotes or double quotes, but I'm going to use single quotes for this one. Just to remind you that Python doesn't really care about them. So like C++. And open this as file, just giving it a name. And then I'm going to read it into a single string. So, normally I would if I'm opening a file, the best thing you can do is read it into a list. And that way it gets tokenized. You use the rsplit function and tokenize it, because that's easier to process for other things. But in this case, I'm just reading it as a massive string, because it allows me to really play around with regex that way and do things. So, yeah. How do we test if it works? Well, why don't we could flood our terminal by trying to say print time machine, but I know. Maybe I can use list comprehension. Let's say maybe print out from 0 to the 20th character. Will that work? Maybe. Good refresher. Yeah, that worked. So that's the beginning. So if we go up here and look at our book, you can see that's the beginning of the book, right? In fact, here, for some reason I thought 20 characters would be a little bit more. Let's do 100. See that? Let's just get a random spot. So let's get character 5,000 to 5,100. Any bets on what that's going to be? Has only 2 dimensions. We could represent a figure of a 3-dimensional solid. Okay, I guess that must be from the beginning of the book when they're talking about time travel. Maybe. I'm curious now what it says. And similarly, they think that by models of 3 dimensions, they could represent one of 4 if they could master perspective of things. See? I think so. Okay. So yeah, that's probably when they're on the dinner table. Well, spoiler alert if you haven't read the book, but maybe watch the movie at least, the old movie from the 60s, I think. Then you have some context, I guess. But the book is good too, and the book is really short actually. It's 100 pages maybe. It's like you read it when you're a kid, so it's a really fast read, but great book. But anyways, besides the point. Okay, so it worked. We basically read the string. If you want to see what the ending of it is, my negative practice of this. Let's see, so maybe like that to that. It's gonna give me the last few characters. Let's see if I didn't put those backwards. No, yeah. So produce our new books and how to subscribe to our email. Yeah, so that's probably some Gutenberg banner at the end. In fact, here let me scroll down to see what the end of the book is. Let's bring that over again, so you can see this website includes product information about Project Gutenberg, how to help produce our new ebooks, and how to subscribe to our email. Yeah, so that's literally the bottom of that. A lot of this stuff, by the way, was crowdsourced. I think some of the books are so old that there's, OCRing is good, but it's not perfect. So they need a lot of people to go in there and actually transcribe the books or copy them from paper to actual digital. So I think they're requesting volunteers still. So yeah. Anyways, we got it. We read it in. Hopefully we reviewed now how to open files. So let's actually start playing with regular expressions and run that and see how that goes, okay? So the first thing is, how do we use regular expressions in Python? Well, Python has a library for that. Python has a library for everything. There's the anti-gravity library even, right? So try that out, by the way, sometime. In this case, this is really nice because it's just import RE. And if you downloaded Python, then you probably have this already installed. So you don't need to like pip install regular expressions or anything. It's kind of like built in. So it's kind of like import system. So that's pretty nice. A way to test if it is for sure built in is just, try to run the code and see if it runs. And if it doesn't, then, Google how to install or contact me or whatnot. Okay. So before though, I go in and, let this free on like a book that is, how many words is it, by the way? Well, we could do that in Python. We could count it. But I'm just gonna go over it quickly. There's about 3,500 lines, and I don't know if each of those has like 10 words in it. Then which I think is viable. We're talking about somewhere over 30,000 words. Okay, 35,000 words potentially. That's a big file. However, let's just test the basics and see if what we set up will work. Okay, so let's just test it on a simple string. In fact, we can even try to do the marker example again. Okay, so let's start by showing you the search function. Yeah, this is a search function. So let's create a little variable, just a test variable. So I'm just gonna call it like a test. And then in there, I am going to store a string, which is the one I had before. So I am writing on the board with a red marker and a blue marker, period. Okay? So I have a string with that. And now let's try to search for a pattern in this string and store the result in a new variable. So I'm going to call this result. And I'm going to use the regular expression library. So I'm going to put RE, by the way, read the description, it's very useful. RE, supports for regular expression. This module provides regular expression matching for operations similar to those found in Perl, that's a different programming language. It supports both 8-bit and Unicode strings. Both the pattern and the strings being processed can contain null bytes and characters outside the US ASCII range, ASCII table. Regular expressions can contain both special and ordinary characters, etc., etc. And then it actually gives you a little summary of those meta characters and whatnot. Lots of good documentation. You can also go to the Python's website and read the documentation on regular expressions. It's actually pretty good. Okay, cool. All right. Now let's put the magical member access operator dot, and we have the list of functions that we can run amongst other things. The main ones that I want to play with are going to be find all, but right now let's just try the simple one, which is the search. So what is search? It says here, search, scan through string looking for a match to the pattern, returning a match object, or none if no match was found. So that kind of sounds good. All right. From there, it's going to take two parameters, and you can see what the parameters are right here, which is the first parameter is the actual regular expression. The actual, the code of the regular expression of what you're looking for, that pattern, which here is called the any string search, or a scan through string looking for a match pattern, return a match object. Yeah, so that really named just any string. And then the second one is going to be either the string itself or the variable name that stores the string where you want to look through. So like this will be the time machine right here, but we're going to test it first with a test string. Okay. So for now, let's go ahead and just do an exact match of marker. And then for the string, we're just going to pass the test string. Now, if I run this like this, nothing's going to happen. I need to print out my results. So for now, I'm just going to go ahead and say print result. Now, I could have just wrapped these, by literally putting this inside of the print. But, keeping it simple for now. Let's go ahead and run the code. Here's what we get. We get a little weird thing, is it doesn't look like a nice font, but if you remember from the classes video in 621, this is an object. In this case, it's called a match object, and it has its own sort of syntax for printing, for the print function of the class. But it tells you what we're looking for, which is that there was a match. But it's kind of weird. It's kind of giving us some numbers. Now, what do these numbers mean? Well, for that, let's go back to this website. If you remember on this website, well, not remember, if you noticed when we're looking for like markers. So here, let's type in marker. Over here, there's some match information. So, there's multiple matches. It tells you there's multiple matches. It gives you actually this range of numbers. and then what the match was. You can see the two of them are the range of numbers. What these numbers are is the position in the string that that match is found. What this is saying is it is the 60 to 66th like character in the string. Now let's make this simple just so that we can actually see, you know, not have to count to 60 to see if that's right. So I'm going to say I am marker. It's very meta. As you can see, it says 5 to 11. So let's go ahead and count. Let's start trying to count from 1. So let's go 1, 2, 3, 4, 5. As you can see, 5 there would actually be the spot before. Why is that? Well, because remember, when you're counting in C++ or in Python or, you know, things like lists and whatnot, they don't start from 1, they start from 0, right? So if you start doing it that way, we say 0, 1, 2, 3, 4, and 5. So then we actually go to the M. So technically speaking, even though it says 5 to 11, you know, I would say that it is actually the 6th character in the string where the match is. It's position 5 because it's the index of that location. And this indexing system starts from 0. So that's why you see a 5 there. And it ends at 11. So let's see if that's true. So that's a 6. And then we got the R at 7, the K at 8, the 9 at E, the R at 10. And then you see 11. You're like, huh, why is that if this is really at 10? Well, you know, if you're using the index I'm talking about with starting from 0, this will tell you the index of the next available spot per se. You can think of it that way, okay? If you really want to think about it from index 1 so that the 11 matches that, you know, then that could work too. You could just say this is like 1, 2, 3, 4, 5, and then the next available spot is where it starts from 5. But that's kind of weird. I don't recommend you do that. Do from 0, like I'm saying, because it's 0, 1, 2, 3, 4, 5, and that's where it starts. And then think about like a for loop, you know. You don't include the end spot. You include the beginning spot, but you don't include the end spot, right? Like in a range-based for loop. It's kind of the same thing here. That's why it says 5 to 11, okay? So that's what these numbers represent. And that's what you're getting over here in Python. You're getting the number of the locations that it's saying that this is actually 37. So, you know, if I switch this to that meta example of I am marker, and I write on it again, you'll see the same thing, 5 to 11, right? Now there's one catch here though. As you know, if I go back to here, or here, let me just copy and paste this. If I copy and paste the exact same string to the website, see how nice that website is? Hopefully it never goes away. You know, who owns this website? Contact. No, it just links me to an email. Bracket 101. So I don't know. But the sponsor is Doppler. Oh, okay. Give the guy like a sponsor. That's good. Okay. So anyways, don't DDoS this website or anything. Be nice with it. But yeah, you can see that you have two matches, right? In this case, though, if we run it with a string, we can see that we only have one match, right? We have the 37 to 43 from here, so that match is there. Here you can see them side by side. But the second match is not there, right? So you're like, huh, why doesn't that work? Well, it turns out that the search function is only going to usually return to you the first match that you find, okay? Now let's see what happens when it doesn't find a match. So instead of finding the word marker, I'm going to look for the word markers, plural. Run it, and then you'll see the word none. So as you'll see in the documentation, whenever you're searching for a match, if there is a match, it will return to you the location of that match. And when it finds a match, it just stops. It's like, okay, I found a match, I'm done. It doesn't keep going. So this is like a find the first match situation. There is another function called find all, which is going to return to you matches when there is more than one. Okay? So that one is more for like an exhaustive result. And I'll see that in a second. I can actually, I think I can just run it right now really fast. I think I might have to run compile on that first, but let's just try it, see what happens. Yeah. So I have to run it on compile. So I'll return to search to the find all in a little bit, okay? So you can see that. But for now, let's just stick to running with search all. Okay. Or maybe it's because I was looking for markers. So here, let me try that. Okay, and then let's go for find all. There we go. Okay. So find all will return two matches. But as you can see, that it's not really telling you the indexing location of that, right? So it's just kind of like telling you, like, yeah, we found 2 matches. Have fun looking for them, kind of thing. I guess you could then run that on the search or something. But yeah, like I said, we'll come back to search and look at more details. Or sorry, we'll come back to find all and look for more details. Okay. So search will give you that first return. And okay, now that we know that this works, why don't we go ahead and try it out on the, we'll comment this out. Let's try it out on the actual book, okay? So this is the part where I ask you volunteers of, you know, what do you want to run or look for? But for now, I'm just going to come up with some examples. Let's try to do, digits. Yeah, let's try to do digits, actually, because I want to talk about this. Very interesting, okay? So as we all remember, well, hopefully, there are special characters in regular expressions, you know, so if you want to search for all numbers, you can use the shortcut of D. And of course, remember that when you do uppercase D, or uppercase of these sort of special characters, it's like the opposite. So like find everything that's not a number, right? But in this case, we're trying to find all the digits. That's a better term, not numbers, digits, okay? Normally, this will be what the backslash would be. So like if I try that over here, oops, \D, it says here, matches a digit equivalent to 0 to a 9, right? So that's actually, yeah, that's true. That would be the equivalent of me writing it with the square brackets like this, 0 to a 9. Now, if I go and put an uppercase D, matches any character that's not a digit equivalent to 0 to a 9. Yeah, okay. Interesting. That would match like that. But yeah, okay. So, if I go in here and put a 1 or something, and then switch over. Of course, it's matching literally everything of the string except the 1. But if I switch it over to 1, as you can see, it matches the 1, right? Okay. So hopefully that's a good refresher. So, let's try to just look for all digits in the book. Okay. So like, I don't think there's page numbers in here, but there's probably some form of numbers in here. Actually, I think I was one of the ones that I was testing ahead of time to see if we got numbers, and I do recall getting some numbers back. So we should get some numbers, but I was surprised. It's very few numbers. So, okay, this should return at least the first number. May not return particularly all numbers, but yeah. Now there's one issue here, right? Python's not gonna like this because it's gonna think this is an escape sequence character, right? So we gotta make sure we put 2 of them. All right, now we're ready to run it. But let's make sure we show the results. Let's go print results after it, and let's do it. Sorry. I forgot to put in the second argument, which is the name of the string, or the actual string itself. In this case, it's just an time machine. Okay, run it. See, and we do have a match. We have a match for the digit 1. It was found in the spot 576. To see what that is for now, let's go ahead and print out from the time machine. So it was what? 576 to 577. So maybe let's print out from spot 550 to 600, so we can kind of see it. Oh, so it was a release date. Okay, makes sense. Release date, July 1992. So, okay, there you go. That's 1 digit. In fact, let's see a little bit more. Let's do like 500 or 700. Most recently updated October 20 language. Oh, here. Author, title, author, release date, July 1992. So as you can see there, that is indeed a number. So we are in fact successful in finding the match. Okay. However, this is not that cool. Also, what if I wanted to find a backslash in this? Like, just a backslash. Let's see if there's backslashes. Bam. Bad escape. End of pattern. So it is yelling at me. It does not like me having a backslash there. So why is that? Because let's think about it for a second. In fact, for this, let's switch over to the iPad, okay? So what I want to do is I want to send the regular expression of a backslash, right? However, that backslash cannot work because it's a special character. So what do I need to do that? What did we do to fix the issue with the dot? Is we put a backslash in front of that. So, okay, so we put a backslash in front of this. Cool, all right, so we know that this is exactly what we want to send, right? But we can't do that in Python, because if in Python we just put this, Python is thinking that all you want to do is send this, but we want to send two of those. So what do we have to do? Well, we want to put another one. So we're like, okay, let's try 3 of them. What is this Python going to interpret it as? Well, that's going to interpret it as this will become 1/, and then this is just going to get confused and give you an error. So what do we have to do? Well, we have to add one more. So we end up actually with 4 backslashes to have the equivalent of this being 2 backslashes, which then the regular expression is actually going to look for a backslash. Okay, so this is what we feed to Python. Like, this is the Python layer, this is the regular expression layer, and this is actually the real regular expression, the actual match. Okay, so if we're looking for a backslash, we need to put 4. I don't know about you, but that's like, oh, that's kind of nasty, right? And so I'm going to show you a way to at least cut off one of these middle persons, cut off that part. So at least instead of having to put 4, we put 2. We're not going to get away with putting less than 2. Like that, there's just no way around that, unfortunately. But at least 2 is not as bad. 2 is what we're used to in Python. Like whenever we're trying to print out something in Python, you know, with just a slash, we would just put the top one, right? We just go with this. But the 4th one is just like, it's overkill. Like it's just insane. Like if we're looking for like a string that has 2 slashes, like this is the actual match that we want, 2 slashes. Let's see how many slashes we would need for that. We would need 1 extra for each of them, just to have the actual regular expression. So this is the regular expression that I would have to feed, which means in Python I would need twice that amount. So I need 1, 2, 3, 4, 5, 6, 7, 8. So this will be the Python string. So that it becomes this regular expression, so that it looks for this match. For 2 slashes, okay? So this is like exponential. Well, not exponential, but it's powers, right? Like powers. So like, yeah, not cool, not cool. It's so yeah. So we don't want to go there. So there's a solution for this. Like I said, it's a solution to at least cut this pain a little bit, to ease our pain, okay? But before I do that, let's go test out this double slash fun. The 4 slashes, just to search for a single slash. To see if the book has a slash in it. It's gonna be very sad if it didn't. None. Oh, it has no slashes? Really? Like, really no slashes? Let's prove that. Let's Control F. A slash. Yeah, there's really no slashes. That's so tragic. Okay, you know, let's go ahead and actually add in the slash, like sneak in a slash in there. So to see, because otherwise we won't know if it works, right? So I'm gonna go ahead and I'm gonna change we know that the character of like somewhere around 500 is the S from this ebook thing, right? So I'm gonna go in there and like change character 520 to be a slash. Okay? Which I guess I need 2 slashes for in Python. Okay, so when I do that, let's print out a little bit before here. So this is like 450. So when I do that, this should now give us a match. Let's see. Oh, that's right. In Python, you can't edit strings. They're immutable. So we have to make another one. Fun. Well, let's just append this. Well, we could append a slash at the end, or we can concatenate 2 strings. But you know what's easier than all of that? Let's just manually add a slash to our file to avoid, you know, having to do a lot of Python code that's unnecessary for what we're doing. So let's just go in here and let's just throw in a slash right there. And we know it's in this word grappled. I don't know where that's at, but yeah, okay. it feels wrong to put that slash there, so I'm gonna undo it in a minute after we test it. But yeah, okay. So I don't know if that's anywhere near this. Let's comment that out. So this should now return yes, and yes it does. Here we go. We got a match. Oh, that's pretty far in. And the text, I guess, into that line. So let's go ahead and actually print that if that is where we put it at. So 39900, and let's just do like 39999. Okay. And Hing set my teeth and again grapple fiercely, wrist and knee with the machine. Oh, ooh, this is using the machine. That's cool. So yeah, so as you can see, it does work. Okay, so I'm not lying to you. We have undone that. Yeah, sacrilege to change the book. So I fixed it. Okay, I feel like I'm writing in a book or something. It's not right. Okay, so yeah, not cool. No, not cool. Oh, actually, you know what? Let's go and ruin the book again for a minute. Oh, that's cool. It remembers where I'm at. Let's leave it ruined for one more minute so I can test something. Okay, I'll show you. So we're still getting the same result. Cool. But like I said, this is not cool. This is not cool. How do we make this better? Okay, for that, I would like to show you something really cool in Python. This is one of those things that I could have shown you in 621, but it's unnecessary until you actually want to use it, and then you're like appreciative that it's useful. Otherwise, I would have shown it to you and you would have forgotten it 2 seconds later because it's like really irrelevant unless you have this kind of situation. And that is what is known as like the raw text mode, okay? So normally in Python, you're not using the raw text mode, but it can be useful when you're running into these kind of weird scenarios like this escape sequence and whatnot, okay? So what the raw text mode is, well, let's think about what the normal text mode is first. So the normal text mode is basically like when you're writing a Python, like a string in Python, you say like hi, you use something like tab, I am, and maybe you do like a line feed, and if you're trying to do happy and then like comma quotes, you can do the backslash that I was saying. He said, maybe like another backslash. Okay, I know that makes no sense now that I see it in terms of the sentence itself, but don't worry about that. Put a bunch of numbers or whatever. Okay, and then finish the quotes, okay? So this is an actual legitimate string in Python. And here's your opening and ending. And we have special things in here that are controlled with escape sequences, such as this is a tab, this is a line feed, this is a quote, this is another quote. I could even put 2 slashes in here somewhere, like there. That's going to be, again, a slash printed out. So like what this output text is going to be hi, some space for the tab, so I'm going to put some lines to represent that. And then say a slash, I guess. Slash I am, and then the line feed, so we're going to start here. Happy, comma, and then a quote. He said a quote 22, right? So that's what that output is going to look like. And that's because this is like the special Python string mode where it knows to convert those things to allow you to format your text and do some other interesting things. Okay, so wouldn't it be cool if there was a way to turn off that system so like you could just put text and it copies it exactly how it is. Like it does not do any line feed, nothing. It's literally going to be like raw. Well, yes, there is, and it's called the raw text mode, as the name implies. And so this raw text mode, what it will do, and well, actually, let me show you how you do it first and what it will do. So all you got to do is in front of your string, put the letter R. So like literally the letter R, and then put your quotes to start it and to end it. And again, doesn't matter. You could do single quotes or double quotes. It works either way. And then go and put in your string. So like I could go in and put the exact same string. So here, let's just copy and paste it. So, imagine this is in a print function, I guess. So now let's go ahead and do the same thing. But let's put this magical R in front. And I'm going to shrink it a little bit so it fits. And then go ahead and put in your same string. So what is this going to print out? Well, it's raw mode, so it's literally going to print it out verbatim how it is. In fact, I guess if you know latex, which I doubt many of you do, but if anybody watching knows latex, this will be kind of like verbatim mode in latex. That's what it's called. So yeah, but hey, don't feel bad if you don't know latex, by the way. I didn't mean that in a negative way. I'm just saying latex is like, programmers like to use it to write cool Word documents per se, but Microsoft Word is just fine too, so I don't feel too bad about that. But latex does make things look pretty. All my publications and stuff I have to do in latex because that's what the standard is in engineering most of the time. But don't, I miss Word. But anyways, getting a little bit sidetracked here. What is the text going to look like? It's going to literally look like hi, \t, \/ I am \n, happy. So this is literally what's going to get printed out or written to some file or something. It's raw mode, so it's literally the exact same thing I wrote. It's not making any of those conversions. I guess no quotes though. That's what you're going to see. So in the normal scenario, like you probably don't want to do this unless you have a lot of weird escape sequence characters and you just want to be able to print the text out, then it could be useful. But for most cases scenarios, you don't want to use this system. Regular expression though, it's a scenario where you do want, because it avoids the weird / issue. Because then you can actually just feed in your regular expression exactly how you want it and not worry about Python like messing with it, such as like issues with the backslashes. Okay. So if I do that, all this much knowledge just to do one simple change here. But trust me, this is actually useful for not just regular expressions, but in general in Python. I can convert this line right here into, put an R here, and put just 2 slashes. Now if I run this, it's coming out this one, I should get the same result. And I do. So there you go, all of that from that. But as you can see, I save having to put the 2 extra slashes because of the escape sequences from the string. And now this is literally my raw regular expression, and it's going to be taken verbatim as it is. So yeah, that's raw mode, and I really wanted to bring that up. So this was, I think, the great place where it's actually useful. And now you learn it and you actually appreciate it and you could actually use it and not just forget about it in 5 seconds like any normal person would have, because you're like, why would I want to do this? It's kind of random. Okay, so yep, that's I think that's good for now. Let's see what else I want to do. I'm trying to think if there's anything else I want to do before I show you like the find all, which I think is more kind of useful. Trying to look and see if there's anything I'm missing. Okay, maybe I can show you, and of course we can run fancy here. Let's just actually let's run one fancy like pattern here, search pattern, okay, so that we can see it. So like let's do I'm gonna leave that comment that I have as well so you can play with these. Let's do oh wait, before that I want to fix the text. I'm tempted to look for something fancy and then come up with it, but I want something to like truly discover something useful about this. So like for example, let's see if the word "the" is followed. When is the first instance where the word? Actually, well, that's kind of generic. The word "who" is followed by another word. Or actually, no, let's look for a pattern. In fact, the time machine itself is a pattern, right? So I could see like, hey, look for a sentence that has the, and then something, and then machine, okay? And let's see if we can find a pattern like that. Yeah, and then we can flip it and find something that doesn't have the word machine, but has a word like a word in between, okay? So let's first play with it here and then bring it over. So like, for example, the time machine is cool. that machine is cool, is crazy. The time the infernal machine is madness. Okay, something like that. So what I'm trying to say is I want to find the pattern of the and machine regardless of what's in between. Okay? So what can I do for that? Well, first of all, I'm going to have issues with the uppercase and lowercase. I don't think this is a... I could force everything to lower before I start matching to see if so I don't miss any upper and lower case of matching. I believe I could just run that with Python. Yeah. Yeah, that might be a good idea to do that. Yeah, so let's just do that really fast. So when I read this, I'm gonna go ahead and say time machine gets time machine dot lower. So I'm just gonna lowercase the entire string, just so that I can find matches. Because like, what if like da is uppercase or machine is uppercase in some scenarios and other ones it's not? I don't think it might make a difference, but just in case it does, okay? So we're basically lowercasing everything. So we have, so now whether the machine is uppercase or lowercase, we're gonna find it. We could also just do or and then make the variations ourselves, but I think that's a fair simplification. I mean, one of the first things you do when you clean up text is you probably lowercase everything. So I think it's a fair step to take without quote unquote cheating. So yeah, okay. So we know we need to put da, and here let's just actually write it out first. We know this will do like a match, but actually that brings up a good point right now. So we can't just put this right now as a match because there's a space. So how do we actually put in a space? Well, I believe it's the // right? Oh, am I overwriting? I have to overwrite. So the time machine. Space there and a space here, right? I think that one's oh, save. Ooh, linked regular expression, that's cool. I think is there I thought that S would give us a space. Matches any white space character. Why does that not match? Huh. Matches any white space character. Oh, it's matching like those white space characters, returns and whatnot. I just need a space. How do I? Let's see. I think I guess I just need single quotes. If Google is to be believed. Oh, that did not work. Maybe that like I can't just do it on the web page. I mean on this web page, but I can do it on the string itself because I can't use quotes. Someone says that this could work, so let me try this first. Blank. Not sure how to. I think that's something this website's doing. Let me try it directly here and see if it would work to just find a space. So let's just try that. Yep, So that's something that the website's kind of limiting me on. Huh, really? Well, I guess we found a limit of that. Interesting. Interesting that we found a limit like that. I feel like, let me try something really fast here. Yeah, okay. I guess we found a limit of that website. But yeah, in here you don't have a problem just putting in a space. It'll take a space and be happy about it. It's just that yeah, like if you look at the first two words of the, or not first two, it's like the fifth and sixth or something. Say for da. So like if I want to search for da here, this will work fine. It will actually say for da and put a space in between, and it won't have a problem with that. Am I getting? Oh yeah, ignore that. Yeah, see 80 to 87, and if I go in and actually look at those, you'll see that like let's do 80 to 87 actually. For that, so you see that it's not there's no problem there. It's just like this website. Unfortunately, I can't get it to accept the space because I guess it's just not used to that. So yeah, okay. Maybe there is a way. I just don't know. But that's the website issue. That's not a regex issue. So I wiped my hands clear of that. I thought I forgot how to do something, but I guess I didn't. Maybe I'm lucky. But yeah, okay. So well, I guess we can't really show you what I'm gonna do there. So I'll just go for it right here. But what I want to do is I want to find time machine where like this could be anything, like any keyword. Okay. And of course, it could be of varying length. So it could have inferno, like the word inferno, which would be different amount of letters and different count, different type of letters. So you know I can't go in and do something like a single letter because it would try to match that letter itself. But what I can probably try to do and see if it works is I can do something like that, right? Because the dot is any character and the star is any of that character. However, I think that would be any character repeatedly. That we can actually test here and see. So if I do dot asterisk, I'm gonna just test it with like putting an A and an A in front. Yeah, okay, so that actually does work with any amount of text inside. As you can see, this is a match because we have an A in front and an A at the end, and in between it can be whatever. As you can see, here is good, okay? So in theory, actually, yeah, I could even simplify the query to avoid the issue with spaces now that I think about it. Because all I can say is put this in there, and then machine, and then just make sure this is lowercase. Yeah, there you go. So I mean, even though the website is missing the space stuff, I guess we just found a query that doesn't even require the spaces because I can just use that. I mean, the only downside to that is that in theory I would get a match that says something like this: the teller machine or something. If it's one word, and maybe that's not what I want. Maybe I will actually want it to be 3 words. And in that case, I do need the spaces. But other than that scenario, this would have been an okay query. Okay, so I can leave it like I have right now with the spaces, or I can make it all together. I'm going to try with the spaces. Obviously, this is probably going to match the word time machine, but we'll see if it matches something else later when I show you find all. So let's just run it and see. So it did find pretty much the beginning of the book, which is probably just like the time machine, I think. Span 1 to 48 is literally the top. Ooh, okay. So we got oh yeah, we got an interesting match. Actually, I like that. This shows you this might not be what you intended, but it's technically matching what you asked it to do. So let's actually take a look at that. Let's just print out the first 200 letters. So look at this. This is pretty cool. So the beginning says the Project Gutenberg ebook of the Time Machine by H.G. Wells, blah, blah, blah. So you're like, oh, wait, well, it probably just matched this, right? Well, not really. It actually, the match itself was this. Because you have the word the, which meets our requirement, Then we have a bunch of text, and then we have the word machine. So you might think this is what you're looking for, but this is what you get. So I like that because this shows you like that you have to be very careful that this is what you really want. Because like this is, what I was looking for was like, well, I just want one word, but that's not what I told it. I said, yeah, I want the word the and the word machine, and then I have the spaces because I do put the spaces, and then in between put whatever you want. Like, again, in my head I was thinking one word, but this is literally whatever you want is whatever you want. So like here, you give me a bunch of words. So yeah, in fact, if the book, this is another time machine. This was like, a completely different book, like Dorian Gray or something, and if in the book like the first letter, like the first like paragraph had the word da, and then like there was no machine in there until like the last sentence of like the last chapter, that whole block of text I would have gotten back in this query. So interesting, and I think I'm glad that this came up because this does start to show you that the power of this, and like great power comes great responsibility. You gotta really think it through if that's the pattern that you're looking for. Okay, so very cool thing. All right, let's go ahead and move on into showing you find all and ways of actually matching more than just the first match. Okay, because otherwise, like, we'll be here all day, and then you won't get to see. You won't get to see like how to find out how to do multiple matches. Okay. So for multiple matches, we're going to use the find all method, okay? So for that, before I do that though, I'm going to show you what the compile method is, okay? So let's go ahead. We can leave this lower in there. That's fine. Let's just comment this one, and then let's just do that up here, okay? So when you are creating your regular expressions, there's a method called compile, and you could read the documentation on Python for more details on how it works. I really want to skip that to save some time. But ultimately, you want to prepare these sort of regular expressions pattern searches that you want, and what compile does is it sort of prepares it. And it's for efficiency and other reasons, okay? So let me just go ahead and show you an example of that. So let's do the one where we're looking for the digits, okay? So I'm gonna go ahead and use my raw mode, and then I'm gonna put D, and then maybe I am looking for not just a single digit, but multiple digits too. So I'm gonna go with a plus, right? One or more, not zero or more, because otherwise I'll get literally everything, but one or more. Okay, so once I create my query, and this is just like query, it's not really like related to any search, like any file or anything. Then I can go ahead and feed it to something like the find all method. Okay, so in fact, I'm going to use the word Q for query. So if I go ahead and say result, and then go ahead and say Q, and then I use the find all method that I was talking about. Then I feed it the text that I'm looking for. Then this is going to get us a very much more interesting result. So as you can see, it gives us all of the matches as a list. As you said, well, you did see the listing in the beginning, right? So you don't have to use this compile thing. You can do the find all, how I did it at the beginning of the video. But when you do it like this, you actually get more information out of it that you can play with. So what this is doing is this is literally saying these are all the matches that contain numbers in it. We know this is probably because of the I think it was like the first publish or something, release date. Yeah, release date. And by the way, why you might be like, whoa, why is it released in 1992? That's whatever, like, I guess this version of the ebook that Gutenberg Project did. Gutenberg Project is an old website, by the way. That's probably like 1982 is when they did it. And apparently there was an update October 22nd of 2020. That's where this comes from. I wonder what that is. They probably like updated like maybe a typo. I doubt it. Who knows? Maybe they just formatted something different or changed the banner at the top or bottom. Or maybe just some hard-coded thing and they didn't do anything. But yeah, find all allows you to now get back all of the results, and that can be pretty useful. Um, okay, so from there, let me show you the find iterator. I think that one's going to be useful. I'm just trying to see which one would be good for you to know. Yeah, let's do find iterator, okay? Because what we're trying to get is the match objects for multiple things, right? So like we're trying to get marker, and not just, if we do find all with this marker and marker as we did before. So I can do something like print re.find all of marker in the string test, right? So if I do that, at the end of this, I get marker, right? So what I want to show the tuple that contains the beginning and the end index of those locations, because then I can go and look at that text, right? Just as I've been doing all along using my indexing up here, right? And so you can do that with the find iterator function, if I recall correctly. So let's try it. Okay. So let's do so we're gonna do an iterator. So we're gonna call this iterator, which is any variable, and then we're gonna do p find iterator, and then so basically first here, let me backtrack for a second. Got a little bit excited there. So we got our query, which is to find the numbers, okay? And instead of running the find all method, let's comment that one out. Let me just run this to make sure I commented out everything I want to comment out. Yep, okay. So actually here, let's comment out the marker because it bothers me to be there. Okay, so now from here, I'm going to make this iterator, and I'm going to call the q.find iterator, and then pass in the time machine. So before I go any further, let's go ahead and print out iterator and see what's in there, okay? Callable iterator object, okay? So we have something back, but it's not really very descriptive. So what I'm gonna do is, well, actually, what is an iterator? I'm not 100% sure that I mentioned that in 621, so let's take a moment to talk about that. And kind of go over it. I know we're a little bit over the time, but in my defense, the last video was an hour long, so that gives me a little bit of time. Okay, so and plus, some of the videos might be shorter next week. Good compromise. Okay, so here's the thing with the iterators. When you use a for loop in Python, what you're doing, and you're like feeding it a list. What you're doing is you're iterating through each of the elements of the list, right? So when you make an iterable object, think of it like a list that you can iterate through, and it allows you to kind of work through each of those things. And so this is doing a special sort of version of the iterator that has all of the matches that you can then go through. And what are they? They're actually the match objects that you saw like when I was using search, and it makes a list of them. And so now I can basically work my way through each of them. Now, why doesn't it just print out the list of the match objects when I do print? Because it's a special class that they organize things that way. And so that's why it just says callable iterator. So really, if I want to see it, I actually have to feed this in the for loop. So that's what I'm going to do right now, is I'm just going to feed it in the for loop. And then you'll see that we'll actually get the matches, each individual match that we got. So I'm going to say for match, for each match, I suppose, in iterator. And now I'm going to go ahead and print the match. Should I do match or match? Yeah, let's just do match first. And then I might change that to the span. But I think that will give me the details as you've seen them in the previous examples. Yeah, like this. Okay? So now what we're getting is actually what we were getting with the search function, but not just for the first instance of the match, but all of the instances of the match. Okay? So we can see that 1992 is in this range. And here, let's just take a look at a couple of these. In fact, why don't we, this might be like the last thing we do. You know, I keep having to manually write here, like time machine, and then like putting in like an index that I want to print out so that I can see like the context of what that match is. But like, this is a data analytics class, right? We want to automate this stuff to like do faster analysis about what that match contains. Because like, think about it. Say you're doing this data analytics and like you're looking for some legal terms in like a massive document. If you find a match, the first thing you want to do, like the human mind curiosity, is like you want to go look at it. And you want, you know, it doesn't help just to see the word that you match, because like you know what that word is. If I'm looking for like the word yucca, like yucca man, and like if there's a match, I'm like, okay, like what's the match? Like, well, it's yucca man, because that's what you're looking for. Yeah, cool, but like in what context? Like, you know, what is this talking about? So we want to see that, right? So like right now, what I keep doing is, you know, if I want to find like, let's look at an interesting one. Let's look at this 91. You know, if I want to find that match, what I'm doing is I'm kind of looking a little bit before and a little bit after. So like, that's right on that. So let's look at maybe like 300. Now this is like 200. Going on to 190, 400. So like, I want to see what's in there. I run it. And there's a lot of matches, so let's go down. A full refund of any money paid for a work or replacement if a defect in the electronic work is discovered and reported to you within 90 days of receipt. What is that? Well, that raises more questions than answers. Maybe that's like something in the disclaimer. I guess maybe I should look further. Well, that looks near the end of the text, doesn't it? Yeah, all these numbers look near the end of the text. Let me just scroll down really quickly. Yeah, this is all like this is actually some legal stuff that's at the end of the thing, like the full license and things probably. That's probably where all those numbers are coming from. Let's go ahead and go to 0 there. And run it one more time. Yeah, see, this is probably like the, what is it, the GNU license or whatever license they're using. Actually, what does Gutenberg use? Let me see, or maybe they have their own license. It's just like a public work license that they said. So yeah, this is all coming from like the legal section of that. As you can see that. Yeah. So anyways, what I was going up with this is like, why don't we actually program this indexing system to work, you know, directly instead of us having to do this manually? I think that actually, I mean, as useful as this is, I think that's really what we want. So this gives me a good excuse when I said the word span, what it means. So, by the way, when we print out this object, you know, we get things like span and match and all the things like that, right? But you know, that's not very nicely formatted if you're trying to like process this somewhere else. And so it turns out that you can actually access these things individually by accessing pieces of the match. So like, instead of printing matcher, for example, I could go in and say dot, and then look at all the different sort of member classes. Member functions that you have in here. You have actually, you have span. So like that will print out the tuple. I think that one will work. Let's try it out. Oh, I broke it. Maybe it's without the parentheses. Nope, definitely broke it. How do you run span? Oh, I forgot. I forgot how to run span. Hold on a second. I gotta look in the documentation for that. Match down. No, I think I had it right. Did we break our book when I did this? Oh, yikes. I forgot to print. That's what happened. Yeah, there we go. So this gives us the tuple. So like it just gives you the beginning and the end. That's nice. I mean, you know, if you need to feed that data somewhere else, which we will in a second, that's useful. So we will need that. Bring it back to match. We have this. What other one could be cool to see here? And position. Oh, that's probably just the same value as the, yeah, let's see if that's the same value. Is that a variable or a function though? That is an integer. Okay, that's a variable. Let's print out the end position, and then let's also print out the match span. Those two should match. No, oh, that's just the end position of the entire, probably of the last match, right? Let's see, 199024. Probably, oh, that's actually probably the end of the entire, like, string, I guess. Okay, that's what that is. So you can explore what multiple of these are. I think the one that I might want to show for a second, is there one called match? There should be one called match, probably, that actually has a string if you want it separately. Let's try groups. Let's try that one. Oh, that. Hold on. Need a parentheses there. Just empty ones. Okay. All right. Anyways, let's just leave match for now. And what I was trying to do is I'm going to print out the indexing of that. So after I print out each match, I'm going to go ahead and print out a little bit before and a little bit after each match. So I'm going to put time machine, and instead of hard coding the numbers here, I'm going to say match span, and that's going to give me the tuple. So I want the first element of the tuple. So I think I can just put a 0 there, and that should print out the first element. In fact, actually, before I play it safe, I'm just going to print out if I'm getting those numbers right. So, oh, there's way too many parentheses there. Got a little bit lost. So that's the span, and so of that, I'm going to go ahead and get first element of the tuple. And then I'm going to also print out the second element of the tuple. Like that. And in theory, this should print out the two numbers. Let's just make sure that's going. Yep, that is correct. 589, 591. Yep, okay. So now that I know that works, all I'm going to do is I'm going to write a time machine here. I'm going to go ahead and put it in brackets, and I'm going to put this in there as the first part of it. And then I'm going to put the second part for the ending. Actually, for the ending, what I want to do is I just want to add that in. Yeah, so for the beginning, in fact, here, hold on. Let's simplify this, because I'm in my head this all makes sense, but I want to make sure that that does not get lost when I'm trying to tell it to you. So to do that, let's do baby steps. We're going to variable call start, and we're going to store that number in there, and we're going to make a variable call end, and we're going to store the number for the end. Okay? So now what I want to do is I want to print out a little bit before the beginning so I can get context. Maybe let's print out 200 characters before the keyword that we're looking for. Okay? So we're going to call that like C start for like context start. So I'm going to, this is a number already, so I'm going to take start and I'm going to subtract 200 from that. And I'm going to do the same thing for the ending. So I'm going to do CN for context ending. And for that one, I am going to, this one's a little bit tricky. What I want to do is I want to add what this number is. So I want to add, so I want to take the start. I want to add to that. Actually, no, sorry. I want to take the end, because I know that's the ending of where I want to print. And I want to add to that 200. Yeah, there we go. See, that's actually helped me myself to make sure that I didn't get confused. So that should give me the index before, and then it's going to give me 200 after the end. Okay. This is going to be okay with one exception, and that is I don't want to have a negative index, because otherwise it'll print out the end, or in another language it would crash. And I don't want to have an index that is out of bounds as well. So just to avoid that issue, I'm going to put a little if statement that says if C start is less than 0, then I'm going to make it 0. That's going to fix the issue out of bounds at the beginning. And as for the end, if CN is greater than the length of time machine, then we are just going to make it the last character of that. So actually, greater than or equal to, because if it's equal to, that's out of bounds already. So I'm going to say CN is going to get the length of the time machine in that case, -1. I don't remember if, I think this is how you use the string length. I was getting confused between C++ and this, but I think that's all good. If that's all good, here, let me just run the code once to make sure there's no errors. Okay, no errors. So now I can finally put in my indexing by putting in time machine, and I'm going to put C start to C end. Okay, so this should print out context for each one. And I'm going to go in and in addition to this, I'm going to add in a couple of line feeds just to separate it a little bit better. Otherwise, it'll be kind of hard to see. It's going to be a lot of text. Okay, so let's see if this worked. It's a lot of text. Probably can't even see a lot of the cases, but we can see some of the ones at the end at least. Okay, because again, this is printing out like tons and tons of matches. Might be easier if we write this to a file, but yeah, let's just look at some of these. So look, here we have a match. We have a match for the number. Again, this was all for looking for digits, right? So like, okay, we got a match for a 1. It's in this range. Here's the context. So it should be right around the middle where this 1 is. So as you can see, we have some text before that says s dot if you are redistributing or providing access, blah, 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 blah. And here's probably the one that's matching. And then the rest is the rest of the context. We can see another match here for a 1. I bet you it's this 1. You can see that from here, it kind of cut off a little bit of this because it's kind of shifted forward. Interesting that I cut that much when it's 2 characters ahead. Maybe there's another one. Maybe this one was matching like this one, and now it's matching that one. And that would make more sense as to why there's more space between them. Something like that. But yeah, it's matching that one and so on. Okay, so our context system kind of works. Doesn't work as great, but it's definitely much better than just getting in numbers, right? To better test it, let's go ahead and go back to that. Let's go back. Let's go and do a more interesting query. Maybe let's look for a word. What's the name of Eloy? I think that's how you spell Eloy. Let's try it. Let's look for Eloy matches. Okay. Well, we got some matches, so let's see what we got. So what I had seen of the Morlocks that by the Vi was the name by which these creatures were called. I could imagine that the modification of the human type was even far more profound among the Eloy. Here's Eloy, the beautiful race that I already knew. Then came troublesome doubts. Oops, sorry. It's very sensitive. Why I had the Morlocks, blah, blah, blah. So yeah, so there you go. There's that Eloy right there, as you can see. We could take this a step further, but I'm not. Where you could actually play around with ASCII, like the string function in Python, you can actually color code. You can Google how to do that. It's not something we cover because it's just fanciness that's unnecessary. But you could actually you could color code like the specific index where the text is and make it bold or make it red to make it like more pop out. And then I think that would be a great addition to this, but really slightly unnecessary for what we're doing now. But yeah, I mean that actually would be pretty cool, and then make it even better. Definitely, if you were writing a report to someone, you got yourself this context, you would code that in, how to make it bold, print that out. Now you give your boss a report of all of the matches that you have, and it's nicely bolded, so it's easy to see, easy for your boss to see, and then you get that raise, right? But yeah, so let's look at a couple other ones of the Eloy matches. Among the Eloys, there's probably another Eloy mentioned somewhere in the middle of this. Eloy, yeah, that's probably this match right there. But see, now we're actually getting some good information. Like, I actually know why it's being mentioned. By the way, if you don't know what the Eloy, because you haven't read the book, that's the name of the race. That's like normal humans versus like the Morlocks, which are like the cannibals that eat Eloy and so on. So, homework assignment. Go read the Time Machine. No points for it though, but you'll feel good about it yourself. Here's Eloy again, and so on. And how many matches? There's not that many matches now that I see it. Like, what is this? Maybe like 10. Well, actually, we can see how many matches there are. We can just write in probably the length. Actually, I don't know if that's gonna work, but let's just do a counter. Count, get 0, count plus 1, print count. Match count. 8 count. So I'm actually personally surprised. Like the Eloi are actually a big deal in the book, but it's only 8 mentions of them, and we did lowercase everything, so we're not missing any other ones. I guess they don't. Well, I mean, it's like, if a book is talking about the French per se, they're not gonna say the word French 20,000 times. I think you get the point. They might just refer to them as they, or they might refer to a specific French person and they refer to names, right? So I guess that makes sense. Now we're doing data analysis on the time machine. That's deep. But let's see what the last mention of is, because I'm curious. Necessity had come to him. I even tried a Carlyle-like scorn of this wretched aristocracy. Whoa, those are some higher level words than I remember reading as a kid. But that's good. That's how you learn English, right? But this altitude of the mind was impossible. However great their intellectual degradation, the Eloi, that's right, they're kind of quote unquote dumb, intellectually degraded. That's a nicer way of saying that. Had kept too much of the human form not to claim my sympathy and to make me performance. Yeah, they're basically like sheep or cattle at this point. It's very like a lot of metaphorical thing in the book. But so he's just talking about this. So like looking at the index, the first appearance of the Eloi as a term is 98,000 character. The last appearance of them is 123,000. So that's a very compressed section of it, and then it just moves on. So cool. Now we've done something actually useful. I think you will agree with me that we're starting to actually do a little bit of analytics, aren't we? So aside from reading the time machine as your assignment, I would also like you to since you're all working on your project from 621, apply regular expressions if you're actually looking for anything in particular, especially if your projects involve text. Apply regular expressions to try to explore the text, or if not, then apply it to something that actually may be of interest to you, because this allows you to search for things, and really you're just gonna have to play with all these patterns. I mean, we have really only touched the surface. Like you saw how complex these patterns can be. Between this and using websites like the one I showed you, you can try to come up, and of course if you have trouble with a specific pattern that you're trying to look for, you can always come to me and we can try together to come up with the expression to actually find what you're looking for. But you saw, as beautiful as that example was, where like the and machine, it found everything in between, not how we were thinking about it. So it can get tricky, but it's very, very powerful. And it's not just like think about how this is pretty much an instant result, right? If I were to run code between the loop version and this, the loop version would take way longer than this. This is using like some, without getting technical, it's very optimized to be able to search as quickly as possible. And it's not just for Python, by the way. Regular expressions are everywhere. Whether you're using bash commands like grep or just about any programming language, or outside of programming languages, they're everywhere. So it does benefit you to know them, and I think it's a useful thing to know. You don't have to be an expert. If you're anything like me, when you actually want to do something interesting with it, you just have to pull up the things like all the meta characters, your list of them, and start playing around and sort of building your expression. Of course, if you did this day to day, then yes, you probably memorize this, get it done like that. But you probably won't. You probably just need it occasionally. So I think it's a good skill set to have. So with that, I am going to wrap up today's class. So, we're a little bit over time, but still, I think that it's nice to have all of it in one video. So hopefully between the last video and particularly this video, you now have a good basic understanding of how they work. And just like we did this, I think it's a good example of how the class is going to run, in that, each week, approximately about a week of time, we're going to dedicate to some sort of library or some tool that you can use in your projects or just in general for data analytics to achieve things, whether it be in this case pattern searching or AI like machine learning and trying to predictions and things like that. So yeah, hopefully you learned something today, and hopefully it's something that is actually useful to you and your projects. Okay, so with that, I'm going to sign out. Thank you for watching, and until next time, take care.